Hey guys. So I'm just gonna make a quick little video here, kind of walking you through what we did yesterday. And what we were talking about yesterday were simplifying equations. And in doing that, we were talking about these hanger diagrams that we've been using kind of last week and this week. And so what I'm gonna do, I'm gonna start up here at this top left one, and this is hanger diagram A. So this was A, if you remember, and this was B. This one down here, this was C. And this one down here, this was hanger diagram D, okay? So I'm gonna start with this one and write an equation for this hanger diagram. And so what I'm gonna do is I'm gonna look at this hanger diagram and notice that it has a left side right here and it has a right side. So it has a left side over here, and I'll show that actually. So we can kind of see what I'm talking about. So this is the left side here. So this is left. And then over here, this is the right side, right? It makes sense, right? So there's always, with the hanger diagram, there's always a left and a right. And then with equations, it's the same way. We have a left side and we have a right side. So let's look at our left side here of the hanger diagram. What's happening here? Well, it looks like we have two triangles. And we kind of figured out earlier what the variables are that represent these triangles. And it was the variable y. So if I wanted to write an equation for this guy right here, I could write an equation that is 2y, okay, 2y, so that's the left side. It's 2y because there's two triangles, and y represents the triangles. And then on the right side, I have 1 square, and we found out that the variable x represents the square. So I'm just going to write 1x right here. Now, what needs to go in the middle of my equation? Always, 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 every equation has to have an equal sign. That's why we call it an equation, because it has an equal sign. Equal, equal. You can see that EQU right there, and that's for equal, okay? So it'll always have an equal sign in the middle. So right in the middle, there's an equal sign. On the left side, there's 2y because there's two triangles. There's 1x because there's 1 square, all right? So let's do this one. Let's look at hanger diagram C here. And let's start with what's on the left side over here. So on the left side, we have 1x. So I'll write an x, got my x. And then I also have 3 triangles here. So what would I put here? Let's see, plus 3y. 3y because y represents the triangles, x represents the square, okay? And then on the right side, let's see what we have. We have 2 squares, so we have 2 squares, and x represents squares, so I have 2x. And then I have plus, because I have an additional triangle down here, so plus 1y, so just a y, and that represents the triangle. And notice all the colors match up, okay? So the green, those are our triangles, and the blue, those are our squares, okay? And what am I missing here in the middle? I need my equal sign. There it is, okay? So x plus 3y represents the left side of the hanger, equals 2x plus y, and that represents the right side of the hanger, all right? All right, so let's look at this guy up here. It's a little longer, but it's the same thing over and over, right? We're doing the same thing, so don't get worried. It's a little bigger, but we can do this. So here we have something that's called a pattern, right? And actually, let's look at the left side or the right side first. I want to start over here. So what I'm going to do is I'm going to start off by just putting my equal sign. There's my equal sign. And I'm going to think about the right side of the hanger diagram and the right side of the equation first, okay? So I'm going to start with this. So I have 1, 2, 3, 4 squares here. So I'm going to have 4x, 4x, right? I got 4 x's. And then I have to add, what do I have to add? I have 2 more triangles, so I have 2y. Y represents the triangles, x represents the squares, okay? Now, on this side, we can kind of break it down a little bit more and kind of look at what's happening, but we have two patterns here. We have the same thing repeated. So we have this right here. We have a square and 3 triangles. And then we have another square and 3 triangles. So we have something happening twice. So what I'm going to do is I'm going to write what this pattern is. It's a square plus 3 triangles. All right, square plus 3 triangles. I know what that looks like. 1 square, so that's just 1x right there, plus 3y, because there's 3 triangles, 1 square and 3 triangles. So there it is right there. But here's the problem. I have 2 groups of them. So what I need to do is I'm going to multiply that whole thing by 2. I'm going to multiply this by 2 because I have 2 of them, one here and another one there. So 1, 2. So I multiplied this entire thing by 2. All right. So we got that one. Nice. And then this last one, it's even longer, right? It's even bigger, okay? But it's just as simple. It's just as easy. But I'm going to start the same way because it's a little more complex. I'm going to put my equal sign. And actually, I think I need more room than that. I think I'm going to move it over some. Let's put it up here. I think I could put it here. Put it right here. Okay. So this will be for A. And I'm just putting it up here because it's a little bigger. So let's start with the right side again. We're going to start on this right side where we have 2 circles at the top, 1, 2, 3, 4 squares and 2 triangles. So let's break that down. We found out that z, the variable z, represents our circles. Figured that out. So we're going to use red and talk about our circles first. So how many circles do we have here? We have 2. So we're going to have 2z right there. Those are our circles right here on the right side. And then we're going to have, what do we have? 1, 2, 3, 4 squares. So plus 4x, because x represents our squares. And then plus 2 triangles, or 2y. See how that is? I got 2 triangles, 2y, because y represents the triangles. All right. And now we're going to do a similar thing that we did here. If you start noticing, kind of some of these pieces are in the other equations that we're working with. And that's kind of what we're going to be breaking down in just a second, okay? So if we look real quick, so we have 1 square and 3 triangles. We already know what that looks like. That's right here. That's the same thing as this, right? If I look, I have the same pattern right here. I have 1 square and 3 triangles. I have 1 square and 3 triangles, just like I had here. So we already know what that looks like. It's this right here. So I can just write that in. I have 2 times x plus 3y. I already had that. I already know that. X plus 3y. And this x plus 3y is this right here. And the reason we put the times 2 is because there are 2 groups of them. You see these 2 groups? We got group 1 right here and group 2 right there. Okay, so there are 2 of them. So we multiplied it by 2. But remember now, we still have these 2 circles down here. So we have to add those in. Plus 2z. All right, plus 2z. So we had to add that in. All right, so now what we're going to do, since we figured out our equations, what we're going to do now is we're going to go from step to step to step, because I'm not sure if you've already noticed, you probably have already noticed that this right here is just moving to another step to diagram B, and then the next step is diagram C, and the final step is diagram D. All right, and it goes the same way with these equations. Equation to equation. There's something we're doing to this equation right here to find this equation, to find this equation, to finally find this equation. All right, and you can either use the hanger diagrams, or you can use the equations to go step by step by step. So let's look at the first. Let's look at the diagrams. So the first thing I want to look at is to go from diagram A to diagram B. What happened? What got taken away from each side? Well, we can look at it. What's missing? Well, if I look at that, I can notice really quickly, this hanger diagram does not have these two circles. So it looks like we took away those two circles. And over here on the right, this is the same as this. So it's missing these two circles. So those circles are gone. So we could say to go from A to B, if I want to go from A to B, then what happened? We took away two circles from both sides. So we subtracted two circles from both sides. Okay? So we took away two circles from both sides. Now, what we could also say is we could look at the equation and say, okay, if we took away two circles in the equation, what did we take away? We took away 2x from both sides. We took away 2x from both sides. So we could also say that. So from A to B, what happened? We subtracted 2z, right? 2z from both sides. Okay? And you can look at that. If I take these away, you can see it not only in the diagram, right? When I took that away and I took that away, these diagrams, this diagram became the exact diagram as diagram B. Look, we have two groups of x plus 3 triangles, or 1 square and 3 triangles. That's on the left side. And on the right side, all we have left are the 4 squares and the 2 triangles. 4 squares, 2 triangles. And it's because we took away the 2 circles. We could do the same thing looking at our equation. We took away 2z from the left side. We took away 2z from the right side. And look at what we have left right here. Look at what we have left. The only thing left is 2 times x plus 3y. That's right here. Right? That's represented by the x and 3 triangles in our diagram, 2 groups of them. And on the right side, all we have left is 4x plus 2y. Look right here. This is it. 4x plus 2y. And that's right here. 4x, 4 squares, and 2 triangles. Same as this right here. Okay? And so what I want you to do is continue with this work. I just wanted to give you a video kind of showing you what we're doing, how to think about it, okay? And I want you to continue on working through, going from diagram B to diagram C, and from diagram C to diagram D, what happened in the equations and what happened in the diagrams, okay? Thanks, guys.